So delighted to have you join us, Sani. Sani is a friend of mine. We've known each other for a number of years. She has a doctorate in computing and mathematics. She has a master's in mathematics as well. She has written a number of papers. She has 3 patents. She's an academic. She's an entrepreneur. She's everything. So we are delighted to have her here. We are really honored. And she's going to talk to us about navigating the GenAI revolution. And it's about her journey. So it's real. It's not an academic paper, but she calls it the beyond the buzzwords. So Sani, ball in your court.
Yeah, thank you. Thank you, Reomar, and hello, everyone. So as Reomar said, my background is in computer science, but it's very important to understand that it is not in AI, right? So I'm very much like all of you. When I first, when this whole Gen AI revolution came into being, it was a little bit new for me too. So this talk reflects my experience in understanding Gen AI concepts and actually leveraging those concepts in my startup, Emochart, right? So it's very much reflects what I had to go through. So I presume you have all used Gen AI tools as a consumer or a customer. ChatGPT, I'm 100% sure you have all used it multiple times. But the question is, how can you use Gen AI in a solution that you're building for your customers? Not how you use it for yourself, but rather put it into your solutions, your tech solutions. And in order to do that, you need to have a decent understanding of why Gen AI is an important breakthrough. And the concepts and mechanics of Gen AI, the landscape of Gen AI models that are out there, and very importantly, what you need to consider when deploying Gen AI, right? So let's just start off with a very brief background. Way back in 1956 is when AI research started. And the whole quest is to try to make teach machines concepts and get them to respond like human beings. So it originally started off with explicitly programming machines and telling them concepts like the concept of cat. But obviously that's not going to work, and it was not scalable. And then when hardware became more powerful, around 2012, it was possible to have these artificial neural networks through which you could teach a machine through examples, the concepts, what it is and what it is not. And then you could ask questions, right? And today we are in the Gen AI revolution. And it is similar to telling the machine, hey, go, read this whole pile of information and then asking questions about that. So that's where we are at. So this is the journey. And if you look at machine learning, there are some important concepts or milestones that happened over the years, which you will hear and you should kind of know about. So one is the concept of supervised learning. That is the machine learning from labeled data to predict future values. And the typical use cases for that would be in predictive analytics like stock market forecasting or spam filtering and so on. Then it went into unsupervised learning, where a machine could look at raw data and classify and cluster that data. And the typical use cases for this is customer segmentation, news, the topic categorization of news articles, and so on. And then you went into deep learning, which I mentioned earlier. This is using these artificial neural networks to solve more complex patterns than these traditional ML techniques. And the use cases for this came in terms of self-driving cars, fraud detection, and so on. And today we are with the GenAI concepts, what GenAI brings into being, which is the ability to generate new data similar to the data that it was trained on, and sometimes new behaviors which were not imagined. So the use cases here, and these keep evolving. I mean, what we see right now is chatbots, virtual assistants, AI-generated art, generating synthetic data for other ML models, and so on. So if you take the big picture, this is what it would look like. I've already spoken about these concepts. And then the most important revolution, the topic of the talk, is right here in the GenAI. So what is the breakthrough that happened that made GenAI so popular? It is transformer models, right? Now, transformer models solve a very critical problem that existed in AI, which was known as sequence transduction. So these are big words. So basically, it is about how can a machine efficiently understand relationships between two concepts. Right. So for an example, let's take this sentence. She poured water from the pitcher to the cup until it was full. Now, it here, as human beings, we immediately know it is referring or means the cup, right? Take the second sentence. She poured water from the pitcher to the cup until it was empty. Now here, we immediately know it is referring to the pitcher. But for a machine to know this is not an easy problem to solve. And this is what sequence transduction means. And in the machine learning algorithms, the former machine learning algorithms, it required memory to figure out these dependencies between the concepts. And when the gaps between the dependencies were large, those former ML models became very inefficient. And this was this challenging problem that prevented progress in AI. Transformer models solve this problem with something called attention, which is now built into their encoders and decoders. So this kind of breakthrough happened in 2017 when a senior researcher at Google wrote this paper based on their research called Attention is All You Need. From then on, we have had dramatic advances in this field. So currently, there are two primary Gen AI models, the transformer-based models, which are effective in generating all kinds of text, such as articles, poems, and so on. And you all have come into contact with that, the generative pre-trained models. So GPT-4 is an example. Then there are generative adversarial networks, which are effective in generating visual and multimedia content. And I'm sure you all have come into contact with those as well through DAL-E2 from OpenAI. Now, these models are known as foundation models. So why do we call these foundation models, right? And this is all very important to understand the power of what you get when you use GenAI in your solutions. So those days, AI models, the machine learning models were trained on task-specific data and trained to do specific tasks. So this is what it looked like. The model could do specific tasks. When transformer models came into being, a team from Stanford University predicted that these task-specific models would converge and that it would give birth to a new paradigm called foundation models. And that's why in the literature, when you read something out there, you hear this word foundation model so much. And the superpower of a foundation model is that it's trained on this vast amount of unstructured data in an unsupervised manner. So let's now really understand what this is all about. So this is what I showed you. This is how it used to be, right? The task-specific, models doing specific tasks. With foundation models, if one single model has this ability to drive all those prior use cases and applications, one model, right? And not only those ones, it has the ability to do many more in many other domains. So in the language domain, these foundation models are known as large language models, LLMs, and they are used to generate text. Now, a foundation model with what is known as tuning, or a small amount of labeled data, tuning with a small amount of labeled data, a foundation model can be used for non-generative tasks like natural language processing. Natural language processing is a non-generative task. It's not creating new content. So, but this foundation model can be trained with tuning. Similarly, with prompt engineering, and I'm sure you heard that word, with prompt engineering, a foundation model can be used for classification, right? That means giving it some text and asking it to classify that text as positive or negative, for instance. I mean, we do that in our product on the Emoja platform. So now the question is, how does a large language model, right? When you're thinking of generative, it's important to understand these things. How does it predict this next word, right? For instance, if it's given, if it's at this level of output of it's raining cats and what is the next word? So we know it's dogs. In fact, I just mentioned that word because it's in our brains, right? But how would an LLM know? So that the way, because of the transformer modeling it has, the LLM models the frequency distribution of the data that it was trained on, and this is the largest frequency, so that's why it knows it's dogs. This is what happens, the mechanics that happens behind. So in other words, this LLM is like the world's fanciest autocomplete, right? Basically, that's what it is. Right. And we use it for all kinds of things. So you can just, it's like this wow kind of effect. So you can imagine that it can go wrong because this is what's going on underneath, right? So when it goes wrong, we call it hallucinations. And prompt engineering helps reduce such hallucinations and improves accuracy. So since you hear the word prompt engineering so much, it's at least important for you to know some of the concepts. I'm not going to go into prompt engineering, but the buzzwords that you hear out there. You will hear words such as zero-shot prompting. That is giving a prompt with no examples. So that means the model will be more creative, but also it may hallucinate. Few-shot prompting means giving a few examples, and that increases the likelihood that the model will conform, but decreases that it will be creative. And then there's something called chain of thoughts, where the model performs better if you tell it, show me how you got to this point, explain your reasons. So these are simple things that you can do when you do prompts. And then the other thing is, when you use a model, a foundation model, through APIs, sometimes you're allowed to control what is known as the temperature. So a lower temperature gives more consistency. So, if you use a high temperature, they become very creative, but probably less coherent and so on. So you need to know these things, because when you use a foundation model, you may have to play around with this stuff. Now, when it comes to LLMs, large language models, what is large, right? You have to understand it is the data, the trillions of data that it learns on, it's trained on, the computer resources and the parameters, right? When you look at these models in the landscape, you will see terms like 340 billion, 1.7 trillion. So what does it mean? Basically, what it means is in that artificial neural network, when it is trained on these large data sets, each neuron basically represents that input data in a form of weights, right? So the model weights equal these LLM parameters. And so the parameters are directly proportional to the number of neurons in a model. So larger number of neurons, obviously the model is more efficient. So now, just to recap, we have transformer-based foundation models that can be trained mathematically on a vast amount of data. And these foundation models, because these transformer-based models allow parallelization, they are very, very fast, and they have this ability to adapt to multiple different tasks. And this kind of adaptation, we are still discovering what they can do. So I've gone through the first two topics, and now let's get into very briefly the landscape, and most importantly, what you need to consider when you're deploying GenAI. So this is a timeline of well-known LLMs. It keeps changing. This is up to May 2023. But the reason I'm showing it is now when you see this, you have an understanding. When you see the word param and so on, now you have a sense of, okay, what does this mean, right? And what it could imply to you, right? So if you look at some popular foundation models, there are two types, right? There are the proprietary models and the open source models. Proprietary models are done by these big companies like Google, OpenAI, X, formerly known as Twitter, and so on. So these are some of these proprietary models. The Gemini model is very, very recent, announced by Google. And you have the open source models, which are also extremely powerful. Imagine Llama 2 has three sizes. The largest is 70 billion. Then you have Meta AI's Opt, which is 175 billion parameters. Then you have Bloom, 176 billion parameters, and it is a multilingual language model. It's trained on multilingual data. So you can understand the power, right? So now you are able to look at these different models and a little bit of information about them and know what it can offer. So this is like a landscape shot also from May 2023 of different kinds of models that are out there, which are particularly good at different kind of tasks. And it's color coded to show which ones are proprietary, which ones are open source, and which ones are actually private models. And I will share this slide deck so that, Reomal, you can share it with the students, because I'm not going to go through this now. You can look at it. Now, the important thing, right? How do you adopt generative AI? What are the considerations when you need to deploy it? So when you think of deploying generative AI models, there are about 5 different ways you can do it right now. Right? You can deploy an open source model on a private cloud. This will be done by larger enterprises. You can deploy an open source model on a commercial cloud like AWS, Azure, Google Cloud Platform, and so on, which a fairly mature business could do. Then there is something called MLOps. This is similar to DevOps. Right now, these models, I mentioned that sometimes they need to be fine-tuned. So, companies like Amazon, Google, and so on, they have aggregated, they have created platforms which have a lot of models. They are hubs for models, and they provide everything in the sense that you can just select the model, and in the MLOps platform, you can do fine tuning and everything, right? Of course, you have to pay for that. But some examples are Amazon SageMaker, Google Vertex AI, Model Garden, and so on. Or you can use these proprietary models like ChatGPT as managed cloud services. So you have heard of software as a service. So this is like GenAI model as a service. And in fact, this is what Emojot started off with, right? And then there is a hybrid deployments of all of these. So the point is, you have to navigate the trade-offs when you select how to deploy, right? Because as a startup, right, what you would be faced with is very different to a large enterprise. So as a startup, our mindset is, minimal viable product first, right? So at that point, it's about you have these interesting demos and so on, but it's a very different story when you take a minimum viable product and get it into production for, once you have product market fit. So many startups actually leverage the API-based proprietary models in that minimum viable product stage, the MVP stage, to just kickstart and validate their ideas, right? And then, so this is exactly what we now, Emojot is a early growth stage startup, right? So around November of 2022 is when ChatGPT was announced. And within 2 months, 100 million people around the world started getting accounts on that. So I was one of them, right? And when I saw this power, right, the question in my mind, now we were already early growth stage, the question in my mind was, okay, I know very soon, unless we embrace this technology, we are going to, be taken, will be irrelevant, what we have, right? So it was very important that we had to integrate this technology into our existing solutions. And in order to start doing that, we absolutely went in the path of the GenAI model as a service, right? So we leverage the API-based proprietary models in an experimental way, put them into our products to kind of validate what we were thinking. And we actually had some customers use that. So once the product market fit is established, you can start considering what else you need to do, right? For instance, once you establish product market fit, you might realize that you need to do model fine tuning. So you may have to go to an open source model and you might consider doing an MLOps platform deployment. Or if your scenario means that you're sending you require a lot of responses from the model, or you're sending it a lot of data, it's high throughput scenarios, then you might consider the self-hosting of an open source model on a commercial cloud. Or you might choose hybrid deployments to optimize different scenarios within a solution platform. And actually, Emojot is at this third level right now, because we use it in different kind of ways across our platform. So that means we had to think of hybrid deployment. So then the question is, how do you do this framework? How do you do the trade-off decisions, right? So there are 5 dimensions that you can use to compare the trade-offs. And this, by the way, all this information I'm backing up with sources. So at any point, you can click on any of these when you get the presentation to read up more, right? So the 5 dimensions that you should use is time to market. This is particularly relevant when you're a startup, right? Cost structure, latency, flexibility and transparency, and security and governance, right? This is kind of obvious to you. I'm not going to go into details. I've already talked about it. And here I have a little bit of a table that explains, applies this model to the decision of whether you should use a proprietary GenAI model or an open source model. And, in red, I have highlighted the impact as a startup, the cost structure obviously impacts on margins, and the latency impacts on user experience, which is very important for startups. And some other techniques to build GenAI applications, which you should kind of know what's going on right now, is prompt engineering, retrieval augmented generation, which is programmatically feeding in some natural language data to the models, or fine tuning, which I have already discussed. And in some cases, you might actually be training your own models. So this is where I actually end the talk. As you know, GenAI is amazing. These foundation models are generating so many potential use cases. And what you need to do is not only embrace all of that, but have a very good understanding of how you're going to leverage GenAI, in a proper way, so that as a startup, you can actually go forward and get the margins you need and so on. I have a little bit of time for questions.
Fantastic. Thank you, Sani. Let's see. We have a few questions. Almaha, you want to go first?
Hi, I'm Almaha. I'm very impressed on the work you've been doing, and honestly, it is the space right now. Everyone is going into Gen AI right now. I just wanted to know a little bit more about your startup, Emojot, and how you've been able to use. I'm assuming Gen AI is a majority part of your company, but I would like a little bit to know more about it.
Yes, thank you for that question. So Emojot is in the space of offering solutions to small, we are a B2B solution platform for small and medium enterprises to improve their customer engagement, their customer centricity, right? So that means across the customer journey. So that means it's a platform that has multiple solutions. So originally, when we started this company 7 years ago, so we didn't have any Gen AI, right? So when in November of 2022, we were building a new solution, online reputation management. Then when Gen AI came in, now online reputation management is about when people put review comments on social media, the businesses need to be able to gather all those and actually respond to each review, right? Now, if you take a small and medium enterprise, the people who are reading these reviews and trying to respond may not know all the details or how to respond empathetically and so on, especially reviews which are negative. So this is one place where we inserted GenAI. So we gave GenAI the review and asked GenAI to suggest a response. So in our platform, when you're responding to the review, it just suggests a response, and you can either take that or edit it and so on. So that's one way in which we have integrated. Then another way is we have a social listening platform which listens to the social media chatter for brands. Now, when a brand, according to keywords, now it's listening to the chatter, and it brings in all these comments from all, whether it's TikTok, YouTube, and everything, it brings in to a single platform. This is a vast amount of data. What a brand needs is to understand what topics are being discussed about in that whole chatter, in all these posts. So that topic categorization is another place where we use GenAI, right? So we feed in the chatter and we ask it to categorize it. Right now, in a normal way, if we were using machine learning, we would have to use unsupervised learning, algorithm, and it would have been way more complex. But because we had Gen AI, it was just some API calls, and boom, we have this capability, right? So that's a few examples.
Thank you. Brilliant. And then we have Mika. You have a question, Mika?
Yeah, sure, I do. Shani, thanks very much for your presentation. I think it's really elaborate, at the same time giving the details without, confusing someone, especially who is not an expert. I just wanted to follow up with a couple of things from your presentation. Some could be very direct in terms of responses. Others maybe require a little bit more explanation. And I just wanted to follow up when you talked about, temperature setting for a model. in practice, what does that really mean? I would imagine it's some kind of calibration, but if you wanted to, in practice, what does it mean, and how do I know for, say, the different large language models, for instance, how they are calibrated, and what's the impact of that?
Yeah, so typically when you use a model, even when you're using it through API, you're very right, it's calibration for your usage of that model, right? So you can, when you're setting up your API connections and so on, most of these models will allow you to specify the temperature that you want the model to operate on, right? So what is the correct temperature is a question to be answered through experimentation, because it's very scenario dependent, right? So when you initially connect to the model, you do some test samples, and then you understand which temperature would work for your scenario. But remember this, right? You may set the temperature. Now, models in their, especially proprietary models, keep improving, right? So as they improve, as they make changes, right, then you have to remember to keep checking this, because your original temperature settings may not work maybe 2 months or 3 months down the line, right? With open source models, it's not going to keep changing, because you have now taken that and you're using it. But once again, you need to calibrate, and anytime you have a new version of the open source model, then when you make those changes, it won't be as fast as every 2 months or 3 months. Then obviously you need to be aware of those. Does that answer your question?
Yes. If you don't mind, if I just probe further. So clearly there is no direct correlation between, say, if I choose a higher or more accurate calibration, then I have better results. Is that the case, or you can't immediately say that?
So it, as I said, it depends on the scenario, right?
Okay.
So for instance, right now, that example I said about categorizing the topics of social media posts for us. Now, in that kind of situation, we would prefer if the model is less creative and actually stick to the facts and categorize it properly, right? So in that scenario, we want the temperature set accordingly, right? Lower temperature. But when you are giving responses, the other example I use where you're giving responses to, reviews, right? And you want to be empathetic. Now, you don't want, if you calibrate it to be too, specific, you lose the power of generative AI to read something, give something out of the box, right?
Okay.
And since the person has the ability to modify the suggestion, it's kind of okay to put a better temperature to match that situation. So it's very scenario dependent. I believe in some models, and I don't know which models, you can in fact specify the temperature in the prompt also, if I'm not mistaken. I could be mistaken, right?
Okay. Yeah. Thanks very much. If the others don't mind, maybe I'll just continue if no one has a question. Okay, I'll just go. So maybe my next question is, you mentioned a lot about fine-tuning when you leverage an AI model, for instance, in specific applications. The question I want to know is, let's take, for instance, you're dealing with, let's say, ChatGPT 4 trained on, let's say, 1.7, I don't know if it's trillion data sets. When you're fine-tuning, my question is to know, do you then need to train on the same level or volume of data that was used, or where is the breakthrough with, say, AI helping to train or fine-tune itself? If you can shed more light.
Yeah, so first off, I want to mention that, as I said, I'm not an AI expert. So because we haven't done fine tuning in Emergent, I still don't know too much about that, but I can tell you in general, right?
Okay.
So fine tuning, you use only a much smaller data set, very small. So that's the beauty of it, right? And you basically, so the situation might be that in your solution, you're using generative AI, but then you want to make it context specific to a certain business's knowledge base or something, things about that business, right? So you can choose to use some labeled data to fine tune the model so that then when the model is doing what you want, it is using that additional context to make the responses more relevant. So it's a very much smaller amount of data for fine tuning. And then now you have that retrieval augmented generation is an easier method to kind of augment a model's capabilities and make it do what take data for that you have. Like if you're a law firm and you have this a lot of documents about the cases and so on, you can use retrieval augmented generation to make it relevant to that your internal law firm's knowledge base.
My last question then is about the parameters. You dwelt a lot on the parameter number and stuff. Are there any other things, say, in the choice of what kinds of GenAI tool you want to use to integrate? But are there other factors besides the parameter number that you want to look at?
Yeah. So just a word of caution. I mean, honestly, the number of neurons in the model, right, which is directly proportional to the parameters, makes the model more powerful, right? But just the huge amount of power it has does not necessarily mean that that is the best model for your scenario, right?
Okay.
As a startup, you might what you need to like our use case of topic classification of these articles. Actually, now we started off using GPT, but as we went on, we realized that we needed, because posts out there are in different languages and so on, we realized that Chat GPT, which is very powerful, is not the most suitable, right? And this is after we got the product market fit, right? That after that stage, we have customers using it. So at this point, we are now actually experimenting with different models available, on SageMaker and so on. We evaluate on different platforms to and these models that we are looking at are trained better to do that particular task. So the number of parameters they have is far lower. So it's really a case of knowing what all this means, but not getting carried away with that, just focusing on what you want to achieve and what are your success metrics, and choosing a model that aligns with that.
Thank you very much.
Great, thank you. I'm blown away, Sani. I've been to a number of AI sessions, but this for me personally was very informative. I just ask one question, one last question, and then let you go. And I'm here thinking to myself, yes, you are a startup, and you didn't know anything about the Chat GPT. You saw Chat GPT, and then you started to investigate and you came up with all this. But one of the things that's in the back of my mind, I'm saying to myself is that she is a PhD in computer science, a master's in mathematics, and therefore some of these concepts might just come easily to you. Whereas I don't think we have any PhDs in computer science in my class right now. Maybe there are, but if so, it'll be one and a master's in mathematics. If you were in their shoes, where do you look for this? Do you try to get an AI expert, or what advice would you give?
Yeah, so honestly, this my academic background was not relevant whatsoever when I started trying to understand how I could fit in GenAI into the solutions, right? It was completely immaterial, because what I just like, excuse me, yeah, just like any of you, when I had access to ChatGPT, my mind was exploding in terms of its potential, right? Now, I know what my platform, Emoji platform, does and what we are trying to do for our clients. So as I was, when I had access to ChatGPT, all I was thinking is, what is it that ChatGPT may be able to do to make make something that we are doing more efficient, faster, right? More interesting. So when we were building this online reputation management at that stage, right? We were building it. We didn't even have a customer. And it just got me thinking, okay, now, if you have a small enterprise or a medium enterprise, just like us, and I get reviews out there and I want to respond, right? It's always, you have to think a little bit, what am I going to write as a response to something that a customer is saying, right? And that's when I started taking some responses from Google reviews that were given for various businesses. I just copy pasted some of those and I put it into ChatGPT and I asked it to generate an empathetic response. And I was blown away with the responses it was giving. And that was the aha moment. So I told my team, hey, let's put this capability in this spot. So it had nothing to do with computer science or anything, right? It was just being a normal, curious person.
So that's what we need, the normal curiosity. I said last question, but I have one last question. So you didn't touch on it. How expensive is it to connect with these APIs, or are there like cheaper versions of it, or are there special deals for startups?
Yes. So that's a very important question. So the way each model, remember I said I would recommend going on this, using a proprietary model through an API first when you're trying to validate your idea. And the way they charge actually differs per model, but most of them, they charge by the number of tokens. That means the number of things that are sent to their model in order to get a response back, right? So that is the charging model. And we did a lot of work because on our side to reduce the number of tokens that get sent, because that keeps our costs down. So by doing some stuff on our side before sending it out makes our costs go down. So these are little things you can do. And they publish, right, that this is how much they charge. So you can easily figure out how much it would cost based on that. Then in terms of, are there special deals? Yes, absolutely. All OpenAI and particularly Google AI offers a lot of deals for startups. So all of them have startup programs. And if you sign up, you literally get so many credits that you can use, worth thousands of dollars, right, which you can use. And we ourselves, we are using those.
Oh,
So
fantastic.
that is wonderful for us. So you have to, when you start, once you, in fact, it can kind of guide your thinking on model selection. For right now, the Google AI offers the most number of credits based on our research, right?
Great. Thank you so much, Rani. I know we took a bit longer of your time, but really appreciate you giving us that time. So thank you very much. A big cheer for you. You can't probably hear it, but well done. And if you will share the slide deck, I will share it with the group. Again, really
I will
brilliant.
do so.
Thank
Yes,
you.
I'll email it to you. Right. Thank you. Bye-bye.
Thank you. Bye.